thought she felt the same, but I always am broken-hearted, so here we are again. Seems like we're two different people. I wish we were more alike. I took it all to convince her, but I could change her mind.
I hope you're ready for the final talk before lunch. It promises to be a very interesting one by Jeroen Janssens. He's going to tell us all about how he hacked UMAP and won a plotting competition. I'm super excited. Give him a big round of applause.
Thank you. I've been a long-time fan of Plotnine. So when I heard that Posit was going to organize the first ever Plotnine plotting contest, I, of course, had to participate. And there were some excellent submissions that really showed off Plotnine's capabilities. So here's a stacked area graph. This is actually the winner of this contest. And my own submission was the runner-up. Was the only animation. What you see here is UMAP being animated, right? So we're not just showing the final result, as you usually do, but also all the intermediate steps as well. And here's what the jury had to say. The judges praised both the process of creating the video and the visual style. The aesthetics of this animation evoke a sense of nostalgia, reminiscent of the retro visualizations often found in early machine learning books, which is a very nice way of saying that I've been around for a while. And they're not wrong, right? My PhD thesis has been hopelessly outdated for quite a while now. And now, the Unix command line, which may appear outdated, is relevant as ever. And I can assure you that it's going to be around long after we have retired. And as you will see later on in this presentation, it will save the day once again. Well, and then this Polars book here, which I'm currently writing together with Thijs Nieuwdorp, well, that book is going to be outdated the day it comes out. It's insane, the pace at which they are developing new features. Oh, by the way, Polars has its origins in Xomnia, where I'm currently employed as a machine learning engineer. And I'm here today to share with you my journey of how I created this UMAP visualization. But more generally, and more importantly, I would like to convince you that visualizing the behavior of an algorithm can be very insightful. Right? What do you typically do when you want to get a better understanding of an algorithm? Right? You can read the article, you can study the implementation, or maybe implement it yourself from scratch. Or you just run it a bunch of times and see what happens. So when I say behavior of an algorithm, I'm talking about how the output of that algorithm relates to its inputs. Right? So we have the data, we have the hyperparameters of the algorithm, and the algorithm itself, of course. Well, and the output, there are, of course, the predictions. There is often a performance metric associated or derived from those predictions. And perhaps there's also some internal statistic. And you can visualize this statically or as an animation like I did, or perhaps even interactively, so that you can play around with, well, with the inputs. Now, that's a bit abstract, so here are some strategies. I'm sure that many of you have seen a plot like this, the elbow method, to determine the optimal number of clusters for a clustering algorithm, given a certain data set, of course. And here's a visualization created by Leland McInnes, the creator of UMAP, where we here see one of its hyperparameters. Maybe I can show it again. One of its hyperparameters being changed, and then the output is also being animated. Right? So this is different from the animation that I created. But it's yet another way of understanding Yeah, the algorithm, and then specifically how this hyperparameter influences the output of this algorithm. Yesterday, Vincent Warmerdam gave a very interesting talk. Run a benchmark, they say. They said, it will be fun, they said. And don't be fooled, I'm pretty sure that Vincent is actually having fun here. What he did is he ran a particular algorithm with a whole bunch of hyperparameter settings and then used parallel coordinate plot to correlate the performance metric with certain hyperparameters. You can plot the decision boundary of your machine learning algorithm. Right here on the right, this is what I've used long ago during my PhD to visualize density plots, or to create density plots. And what you see here is how a new data point would be scored, right? And red means being an outlier according to the data set. And this allows you to, well, you can compare multiple algorithms with each other, right? How they are influenced by the data. But also, that's not shown here, but you could, of course, also vary the hyperparameter. What I've done here is I've applied 3 different algorithms, right? These are unsupervised outlier detection algorithms, and applied them to 3 different artificial data sets. Of course, this is limited to 2 dimensions. What I've also done is created artificial data that have hyperparameters themselves, so that you can tweak your data. For example, here in this bottom data set, we have 2 clusters, and I gradually increase the overlap between these clusters, and then you can see how each algorithm is able to deal with that. And only recently, my co-author Thijs Nieuwdorp, he discovered a regression in the performance of polars. So what he did, he benchmarked different versions of polars. I'm not sure if it's entirely clear, but from a couple of versions ago up until the newest release, what we notice here is that there are certain queries that all of a sudden perform much worse, right? And it's now clear where this happened, and I believe that on Monday, of course, the new release of polars will fix this. Okay, so, and then this 6th strategy that I would like to share with you, keeping track of intermediate predictions. That's what I did. So, in this journey, I took the following steps. I hacked UMAP so that it saves intermediate results. I ran it on the MNIST dataset. I draw each intermediate result and then stitch all the frames together into an animation. Right? And of course, I've won it, well, runner-up position, but still proud of it. I blogged about it, and the quick presented refers to the fact that I only learned this weekend that I'm allowed to give this presentation, because unfortunately, Leland McKinns himself was unable to come, and some others. So with this presentation, I do hope to pay tribute to his awesome work on UMAP. Of course, I can't do this by myself. I need tools. And for this particular journey, I used 4 tools. I'm going to introduce each of them briefly. But I want you to know that these tools, they're useful by themselves, right? And you can, of course, mix and match. If you're more familiar with another plotting library, that's fine too, right? So let's start here. UMAP. UMAP in a nutshell. All right, this would be really UMAP in a nutshell, but let's not overdo it. UMAP is a state-of-the-art dimension reduction algorithm created by Leland McKinns, I believe in 2008, inspired by T-SNE. It has a solid theoretical foundation, and I must admit that I have difficulty understanding all the math that's in there. So the intuition behind UMAP, just as with T-SNE, is quite okay. It's quite intuitive to understand, but I wanted to get a better understanding. So let me first give you a few more examples of UMAP. Right? Mostly some pretty pictures to look at. right? So what you see here, they're kind of fuzzy clouds, but those clouds consist of individual data points, right? Data points in a data set, and that has been mapped from, of course, a very high dimension onto 2 dimensions. And I must say that these last 2 plots were created by Leland using his tool called Data Map Plot. I have a link to this tool at the end of this presentation. Okay, so then the hack. And then, of course, not hacking by breaking into some other system. No, here with a hack, I mean a clever workaround to a problem, often involving unconventional methods. And this last line here at the bottom, that is the hack. Yeah, so this line is quite trivial. What was the tricky part is finding where I needed to put this line. So where was this stochastic gradient descent happening? And it's ugly. Oh my, it's ugly. It saves all these NumPy files in your current working directory, right? But it gets the job done. So for my purposes, this was fine. Maybe later on, when the book is done and I have some more time, I'll file a pull request. Of course, not with this hack, but then properly solved. So what I did is I forked UMAP. The code is on GitHub. I forked it. I changed the file. And then I needed to make sure that, the project that I was working on was pointing to the correct UMAP implementation. Here, it's pointing to another GitHub repo, but it can also point to a local directory, a local file. Running UMAP is the easy part, thanks to its scikit-learn-like API. And yeah, so the final embedding also has to be solved, right? Again, the hack is quite dirty. But once I ran this, I had a whole bunch of NumPy files, which I, of course, wrangled together using polars. Now, polars, as I learned yesterday, needs no introduction. But if you do have any questions, come to me or Thijs or the polars team, and we will happily tell you all about it. But there are 2 things that you need to know. Polars is fast. Right? Polars is all the way on the left there. This is before we actually fixed the regression. And polars is popular. Just look at polars go. These are GitHub stars, right? I mean, that's as good as a proxy as anything. Yeah. Did I already mention that I'm writing this book together with Thijs? You should check out our website, polarsguy.com. You can join the Discord server to talk about polars. You can get early release PDFs of the book, and you can sign up to get a notification when the book is out. Well, I'm certainly signed up for that. Okay, so of course we're going to use the MNIST dataset, right? It's been used already way too many times, and it's the dataset, well, that I am at least I'm familiar with. So why not just keep that constant so that we can focus on the algorithm itself? And for those who are not familiar with MNIST just yet, it is a collection of 70,000 handwritten digits digitized into 28 by 28 pixels, which gives us a 784-dimensional space. Yeah, right? And with using UMAP, we're going to embed that into a 2-dimensional space. On the right here, you can see some samples of these handwritten digits. The colors, by the way, are unknown to UMAP. UMAP is an unsupervised algorithm. We're only using color here for our own purposes, right, for inspecting it. So yeah, this is the polars code that I used. I mean, the code is not that important, but just look at it. Look at it. It's beautiful, isn't it? Then the drawing part, my favorite part, I should say. And for this, I use Plotnine, which is, well, the grammar of graphics for Python, created by Hassan Kibirige. And he's been inspired by R, right, the ggplot2 package that, of course, everybody knows who has been using R. The API is very much alike. It's based on matplotlib, and it allows you to create ad hoc plots very quickly, but it also allows you to modify it so that you can create production quality visualizations. It plays well with polars. The only downside I would say is that it's not interactive, so it only produces static plots. And this here, this one-liner captures Plotnine in its captures the essence of Plotnine, right? You give it some data, you say how the columns should be mapped to certain properties, and then you specify the geometry. Now, it doesn't look very pretty, but it quickly gives you a sensible plot on which you can further elaborate. And you can really go to town with this. This here, by the way, is the very first epoch, right? The very first iteration that UMAP is performing. So what I learned by doing this is that it actually uses spectral embedding for its initial solution. Now, I could have perhaps read that in the paper, but I found out a different way. And we can also visualize legend. If you do modify, right, really customize your plot, this is what your code would eventually look like. It may seem overwhelming, but realize that this is often, produced in an iterative manner. So once you understand the API and the underlying grammar of graphics, I can assure you that you rarely need the documentation for this. So I'm a big fan. Hey, all right, so final step. We need to stitch all those frames together. And stitching, actually, there are two kinds of stitching. So we can produce the legend on the right. We can produce the embedding on the left, right? We need to stitch those together. And we also need to stitch all those individual frames together into an animation. So both of these things can be done in Python, right? But due to a couple of bugs, I needed to resort to something else. I looked into the source code of Plotnine. Under the hood, it uses matplotlib. There were some artifacts when I wanted to combine these plots. But I found out that under the hood, it uses a command line tool called FFmpeg. Right? That's always the case, right? Also, all your fancy DevOps pipelines or CI/CD integration, it's all command line under the hood, right? So luckily, we can, of course, invoke this command line tool ourselves. As FFmpeg, it has so many capabilities. Besides what we're going to do, you can turn a video into a GIF. You can record your screen activity. You can add subtitles to a video. It is really, really powerful. Now, this is overwhelming. I would be overwhelmed by this as well. Luckily, it turns out that your favorite LLM is very good at producing an incantation like this. Yeah, so here we take care of the stitching, meaning horizontal stacking, also using FFmpeg, and then a complex filter. If you rather solve this part in Python, then of course you can do that, I don't know, using Pillow or whatever. And then this invocation would be slightly easier. Yeah, so we're specifying two sets of images here. Then this filter complex, which tells, okay, we should combine these horizontally. Then a couple of video settings. And then finally, we get this video, umap.mp4. All right, let's do this one more time then. Right, you can see that the noise is being reduced. Okay, one more time. One more. Hey, so yeah, so lots of noise during the optimization. You can see a little bit of moving around, not that much. I was surprised that it wasn't moving that much. When you visualize TSNE, which I probably should have included as well now that I'm thinking about it, there's a lot more going on. But yeah, I did learn a couple of things here. And that's what I want to leave you with, is that hacking UMAP and winning the contest, runner-up position, wasn't really the point, of course, of this talk, right? It's the mindset that you can visualize the behavior of an algorithm, right? That this can be a really insightful exercise. That's my main take-home message for you. And there are various strategies to do so. You don't always have to hack an algorithm in order to do this. You don't always have to produce an animation, right? And, of course, these tools that I've used, UMAP, Polars, Plotnine, and FFmpeg, they're fantastic and also by themselves. Oh yeah, and again, I want to stress that in the very end, it was the Unix command line that saved the day. Thank you very much.
All right, thank you so much, Jeroen. One more time will be stuck in my head for the rest of the day now, but any questions for Jeroen? Any questions?
No, I think everything was clear.
Yeah, it was so clear.
And of course, you can always come see me after the session. And if you're interested in the slides, which contains all the links to everything that I talked about, you can scan this QR code.
Yes, first, thank you for a great presentation. I'm curious about, given the focus on polars and data visualization and everything, given the recent developments in polars, where there now is also a data visualization backend, is that something that has changed the plans for your book in how you're going to work with data visualizations and polars, or is it going to be used?
All right, I already see Thijs laughing there in the back. You've touched upon a very sensitive topic here, and that is that I had already written chapter 16, data visualization, when hvplot was the default backend. But I should have known better. I should have known that this API was unstable and that it could change any moment. But I was just too excited about using polars for plotting. And so you can understand that when I first heard from Marco Gorelli that the default plotting backend was going to change to Altair, that I was not pleased. Although, of course, now I totally understand why Altair is a better choice for this, right? Especially for having this interactive workflow. And I believe your question was, is the change of the visualization backend influencing the book? Yes, very practically, I have to rewrite chapter 16. Yeah, so the book is probably delayed by a month. Now it's gonna be all right. We expected the book to be available somewhere in January. Yeah.
Hi, Jeroen. Thanks again. I was wondering, since you're very much into different visualizations, do you have a favorite library? Maybe a favorite library for yourself that you like, just like to do like the easy plots, and maybe the favorite library of your stakeholders at Xomnia?
Well, my favorite library, don't be surprised, is Plotnine. Yes. No, really. This morning in the train, Thijs gave me some CSV with these timings, right? You remember the slide where I showed the timings of the different queries that Polars was performing and different versions of Polars. Thijs gave me the CSV this morning, and in the train, I was just hacking my way through this, And what I like about Plotnine is that it's based on the grammar of graphics, right? So it takes some time to getting used to, but once you understand it, it all makes sense, and then you rarely have to consult the documentation. I mean, don't get me wrong, with Seaborn, right, you can produce nice-looking plots. But I personally always have to consult the documentation on which arguments that function accepts, for example, right? And matplotlib, right, well, Plotnine is based on matplotlib, so matplotlib is the OG of plotting, and you can do anything you want in matplotlib, but it just takes a lot of coding. Yeah? Altair, great for interactive visualizations, perhaps less so for creating animations or videos, right? You would have to, it's browser-based. So it's also to say that each data visualization library has its pros and its cons. So I've definitely used others in my work.
But so if you're like left on the, on an island with one plotting tool, it's going to be Plotnine.
Sorry, say again?
I was just wondering, so if you're like left on the deserted island, not accessible by other plotting libraries, with your laptop and just one package, it's going to be Plotnine.
Exactly, and then I'll survive that island.
You will survive on Plotnine.
Yes.
Excellent.
Who needs food when you have Plotnine? Other questions?
Thank you for your presentation. I was just wondering if you could extend Plotnine functionalities like the way you could do in ggplot2, because ggplot2 has a very rich ecosystem of packages, themes, we have GG Animate, GG Teams. So how is Plotnine in that regard?
Thank you. Yeah, so the question was, ggplot, right, the R package, has a rich ecosystem of all these plugins. Plotnine, unfortunately, doesn't have such a thing just yet. And this is all because, well, for the last few years, Hassan has been the only person working on this. So he's using all his time to create this wonderful package. Hopefully now that Posit has adopted Plotnine, I do hope that soon it will have also the ability to add plugins. Because I think that's really powerful. In the same way that Polars has the ability to write plugins for, right? Very powerful. So not yet, hopefully soon.
Other questions? Yeah.
Did you finally understand Riemann manifolds math after this experimentation?
Yeah, it came to me in a dream when I saw this animation again. No, I'm afraid that the advanced math used in the paper will always be a mystery to me. But that's okay. I mean, UMAP is still, I can still use it, right? It's actually, I would say that UMAP is one of the very few algorithms of which I can safely say that you can just apply it, right? The common wisdom is that you shouldn't blindly apply a machine learning algorithm to some data and then expect magic to happen. So I would actually say that UMAP is the exception to that. Yeah. But if you're able to explain the math, no, oh, okay, sorry, no. All right, no worries.
Hey, any other questions? No? Okay, then I would like to ask you to give it up one more time for Jeroen.
Thank you.